Hey guys, today we're going to work on analyzing quadratic graphs. So for the do now, it says a function is defined as all of these points, and Isaac is asked to create one more ordered pair for the function. Which ordered pair can he add to the set to keep it a function? So let's define what a function is. A function is where x values do not repeat. Alright, so that means when we look at the points, we just need to look at all of the x values. So in these coordinates here, I'm going to underline them. This is our x. All these are our x values because remember, in a point, it's always x comma y. X comes first. And same thing down here. We're going to underline all of our x values. Alright, so he wants to keep it a function. What that means is that we can't have any of the x values repeat. So if I have 0 here, I can't have 0 as part of my answer here. So 1 is out. I have 2 here, can't have 2 as my answer. But there's no 2, so that's fine. There's a 5 here, so 5 can't be part of my answer. And finally there's a 7 here, 7 can't be part of my answer. The only one that works is answer choice 4. Okay? Now notice there's a 1 here and there's a 1 for the y. That doesn't matter. As long as the x values do not repeat, we're fine. Also, we see that the y value, there's a 3. There's also a 3 here. It's okay, the y values can repeat. The x values cannot. Alright, let's go on with today's lesson. So quadratic equation, again, it's when it contains x squared. Alright, and we're going to have many real-world problems modeled by quadratics. So anytime we throw something in the air and then it falls back down, it takes the shape of a quadratic graph. It's a negative quadratic, but it's still a quadratic, and we can solve a lot of problems dealing with this. So we're going to have to identify different parts of quadratics and relate them to real-world scenarios. So we're going to label this diagram. I'm going to use different colors to label. So where's the ground? The ground is this red line right here. Alright, this is our ground right here. So I'm just going to draw an arrow to it and say ground. This is also going to be known as our x-axis. Alright, so I'm going to also label this x-axis. Okay, so the ball's path, where does it start? So as we can see, the ball is in this guy's hand. We can call him Bob. It's in Bob's hand right here. And he's going to throw it, and it's going to go from here all the way to the ground. So it's going to take this path. Oh, grab a small piece of the ball. It's going to take this path and go all the way to the ground right there. Alright, so that's what's happening. So it starts in his hand. And what time is the ball? So when it starts, no time has passed it. He hasn't thrown it yet. So t is equal to 0. Usually time is seconds, but it could be different for different problems. And finally, what height is the ball thrown? It's as high as he's holding it. So however tall he is from the ground to his hand. I'm not going to write that out though. So it says, when does the ball meet its maximum height? So again, we're taking this ball. Let's get rid of that. We're taking this ball. And it's going up. And then finally, at some point, it's going to start going right back down. So it has to reach a maximum height somewhere around here. Okay, so I'm going to say that this one, where I left the ball, that's its maximum height. Alright. So that's its maximum height, and it says when does the ball meet its maximum height. So when they're asking about when, they're talking about time. So for this one, t is equal to 5. After 5 seconds, the ball has reached its maximum height. And they ask what is the maximum height of the ball? It's whatever this y value is. So from here all the way up, that's its height. when does the object hit the ground? So again, we take the same ball. I'll make another one here. So we take this ball and we throw it. Goes up, goes back down. Remember, it hits the ground right here. This is our ground, the red line. So when it hits the ground, 10 seconds has passed. So t equals 10. How long has the object been in the air? It's been in the air for 10 seconds. It says, when is the ball's height increasing? So when we're talking about just increasing alone, we're looking at from here to here. So we're just looking at that arc. I'm going to outline that arc for you. So it's from here, up and around. So this is increasing. So you can say the ball is increasing from 0 to 5 seconds. And then the balls, when is the ball decreasing? It's from here down to here. So I'll trace that out as well. Here down to here. And that's when it's decreasing. So you're just going to write from 5 to 10 seconds. Alright, so these are different real world problems that the Regents could ask you. Alright, moving on. So we have this problem here. A juggler is tossing a ball in the air. The height of the ball in feet, that seems important, let me underline that. Height of the ball in feet can be modeled by the equation h of x is equal to negative 2x squared plus 8x plus 3. Where h of x, whenever you see h, you gotta, a lot of times it really means height. So h of x represents the height after the ball after x seconds. So x is going to be time. They usually use t for time, but sometimes they can use x. So they're asking us different questions. It says, at what height is the ball thrown? What is the maximum height? So when is the maximum height reached? Interval of the ball increasing and decreasing. So in order to answer these questions, it's better to graph it. I'm going to graph it on my graphing calculator here. We have negative 2x squared plus 8x plus 3. So when we graph this, we have this parabola, this U shape, upside down U shape. Let's actually graph it on our graph here. So I'm going to go to alpha y equals, and we're going to get a table. Sorry, not alpha y equals, alpha, second graph. That's what I meant to say. Okay. Now when we're graphing this, remember, we want to get a sort of pattern going on here. So we want to see the numbers repeat every single time. Now, obviously for your calculator, it won't show all of these values. It's probably going to show between negative 7 and 7. Negative 7. So that's fine. We're going to copy that over here. So we set up our XY table. We have, I'm going to start with negative 7. So negative 1, negative 7, 0, 3, 1, 9, 2, 11, 3, 9, 4, 3, and 5, negative 7. Okay. So we know that we have a vertex. The vertex is just the middle point right here. Alright? What I like to do, I like to start with that and graph it, and then graph these other points. You can do that if you like. If you don't want to, go step by step with these. So I have 2, 11. Oops. 2, 11. There we go. And we have 1, 9. And we have 3, 9. I know that there's going to be a pattern there. I have 0, 3. I have 4, 3. And I have -1, -7. It's right here. And I have 5, -7 right there. Alright, so there we go. We graphed it. Let me connect the dots. So I connected going from here, going up. Oh boy. Alright, good enough. And then I put arrows to show that it continues. Okay, so we have our graph here. I'm also going to pull up my graph there. Actually, I'll just pull this one over, because this one looks a bit nicer. And there's stuff I want to do with this graph. Now it's good that we graphed it, but there's a lot to this graph that we really don't need. There's some things that we do need that's not there, like the height all the way up here. But there's some stuff that we don't need. Now let's think about this. Let's go back. They're saying that the juggler is tossing a ball into the air. They're talking about height, they're talking about time. So for my x-axis, that's going to be time, because they said x is time. And they're talking about the y-axis, which is just h of x. So I can call it h of x, or I can call it y. They're both the same thing. This is going to be height. Okay. Now let's think about this logically. Can I have a negative time? Can I go backwards in time? No, not at all. So I'm going to actually cut out part of this graph. I don't need this whole thing. Let's see if I can do that. I don't need... Oops. Hang on. So I don't need this part of the graph going back there. I only need this positive part so far. Okay? So I don't need this negative. I just want the positive here. But also, same thing with heights. When I throw the ball, it can't go down into the ground and keep going, keep going. No. This is the ground right here. Remember, I told you x-axis. That's your ground level right there. So I don't need this part of the graph either. The only part of the graph that I really need is this piece right here. Okay? I don't need to go backwards. I don't need to go down any further. This is all I need right here. So that's what that looks like. This is the only part of the graph that I need. Now we still have everything here that we graphed. We have extra information. We don't need all of it. Okay, so let's start answering some questions. So the first one says, at what height is the ball thrown? So where is it starting? Where's the ball starting from? So we look at this cutoff graph right here, and we see that it starts right here at 3. Okay? So when x is 0, that means time is 0. The height, which is y, is 3. So the height of the ball is 3. But we need to remember to include our units. Since we're talking about feet for height, it's 3 feet high. It says, what is the maximum height of the ball? So the maximum height of the ball, we can't see this on this graph here because it didn't go all the way up. But it would be somewhere around here, I would assume. Right there. Luckily for our graph, we did graph it. So the maximum height, that's also our vertex right here. The maximum height is 11 feet. Right? So remember the y-axis, 11. So the maximum height is 11 feet. Now the next one, it seems very simple, very similar, but it's asking when was the maximum height reached? So they're asking for the x value. So when we got the maximum height, when was it achieved? It was at 2, so 2 seconds. So the maximum height is 2 seconds. Now notice that vertex is very important. It tells you the maximum height, and it tells you when the maximum height is achieved. Now it says, in what interval is the ball increasing? Okay. Now this is also going to help us out, the vertex. So when is it increasing? It's increasing from 0 all the way up to 2. It's going to keep going up from 3 to 9 to 11. And then that's it. It's not going to go any higher than that because 11 is the highest point. So you're going to say that it's going to increase from 0 to 2. Whenever we're talking about interval, we're talking about the x value. So you can say from 0 to 2 seconds. Oops. 0 to 2 seconds. Okay. You can also write this out differently. You can write this using set notation. So you can also show it as from 0 to 2 seconds. That also means the same thing. And then when is the ball decreasing? We go back and we see that from 2. Now again, I don't care about the negatives at all, so I'm not using this one. I'm not using this one. So from 2 to 4, it's decreasing again. It's gone 11, 9, 3. So from 2 to 4, it's decreasing. From 2 to 4 seconds. And then again, you can write this using set notation. 2, 4. Alright, and now that's all the questions that we have there. Let's move on to this one. It says a model rocket is launched from ground level. Its height, h of t above the ground, is a function of time t, seconds after launch, and is given by the equation h of t equals negative 5t squared plus 70t. What would be the maximum height to the nearest meter of the rocket? Alright, so let's graph this. Now, luckily, our calculator can do a lot of the work for us. So I go to y equals, I clear out whatever I have there, and instead of t, I'm going to use x. So we have negative 5x squared plus 70t. So 70x. Again, they want to find the maximum height. So I'm going to look, instead of looking at the graph, this one's going to be extremely huge because it's a rocket. It's going very, very high. I'm going to look at the table. I want to see what's the maximum height. Remember, x is time, y is height. So I'm going to label this t. And it says it right here. T is time in seconds. And remember, we're going to use x for this. H of t is height. And it says that right here. Height. And for this one, it's actually going to be y. Because when we type into the calculator, h of t is the same thing as y. So we want to find the maximum height here. So we're just going to look at the y values and see where it peaks. So we have 0, 120, 165, 200, 225, 240, 245. And then it starts to fall. Notice it went to 240 and then 245. And then it goes back to 240 again. Again, what I'd like to do, especially when using a calculator, try to make it so that it matches up. The first number on the table and the last number on the table is exactly the same. It won't always work, but for the most part, it usually does. I'm going to pull this out right here. So, now that I know that these are our values, I just want to see where the middle is. So the middle of all of this is 7 and 245. That's also known as our vertex. Okay. So it says what would be the maximum height to the nearest meter. There is our unit. So the height would be 245. That's the maximum height. Meters. Notice we didn't do any math. We just found the highest point right there. Pretty simple. Now, if you don't have a calculator, what you would have to do in order to solve this is plug in numbers for t until you find the maximum number that you get. You can also do that. That's what the calculator is doing right here, actually. Alright, so we got some practice problems here. Let's just take a look and see what we got. Alright, so this is what you guys are going to work on. Now, hopefully you guys have some graph paper. If not, you can print it out from online, and you can work on this and there. So, this is very similar to the first question that we worked on. They give you an equation. They want to know what's the height of the javelin, the maximum height, when was it reached, the interval, so on and so forth. And then we have another practice problem here. Alright, so I'm going to leave it on this one here so you can take some time. You can pause the video here and you can work on it. And then I'm going to leave it on here for a little bit. Again, pause the video here when you need to work on these two problems. Alright, so I hope you guys are staying safe. Until next time.